this problem is from GATE 2020, Electrical Engineering, Power Systems. In this problem, two buses, bus I and bus J, are given with bus voltages Vi and Vj as shown. At bus I, transformer with turns ratio 1:Ti is connected, and at bus J, transformer with turns ratio Tj:1 is connected. Both the transformers are ideal and connected with a transmission line of admittance Y as shown here in the figure. We have to find the bus admittance matrix for the given system in terms of the turns ratio of transformer and admittance of the transmission line. You can refer to the NPTEL course as mentioned here. The prerequisites for solving this problem are enlisted below. You can take a second to pause the video and see what are the data that will be useful for solving our problem. The turns ratio, equivalent resistance and reactance refer to the primary winding, and similarly the equivalent resistance and reactance refer to the secondary winding. Now a single phase transformer is an ideal example of two-port network with the Y parameters expressed as in terms of I1, V1, V2 and I2. We can draw the equivalent circuit diagram of the system that is given in the problem. Let us assume that II be the current of bus I and Ij be the current of bus J. So the data that is given in the problem is the turns ratio of transformer T1 and T2. Turns ratio of T1 is 1:Ti, and turns ratio of T2 is equal to Tj:1. What we have to do now, since we have to find out the admittance matrix, we'll refer the bus I current on the primary side to secondary side and the bus current of bus J to the primary side of transformer T2. So bus I current refer to secondary side of T1 is II multiplied by N1 by N2. This is equal to II into 1 by Ti, which is our turns ratio, and is II by Ti. Now bus J current refer to primary side of T2 is Ij into N2 by N1. This is again Ij multiplied by 1 by Tj, which is the given turns ratio, and this is Ij by Tj. Similarly, now we can refer the voltages here of bus I and bus J on the respective sides of transformer T1 and T2. So the bus I voltage refer to secondary side of T1 is Vi multiplied by N2 by N1. This is Vi into Ti. Again, bus J voltage refer to primary side of T2 is Vj into N2 by N1. This is Vj into Tj. Once we have done with this, we can see the relation between the bus I voltage current and bus J voltage current. So we can write down this as the relation between bus I and bus J voltages and currents as II Ij equals Y11, Y12, Y21, Y22, Vi, Vj. Here we can see that the Y parameters will be our admittance matrix which is required. So from the equivalent circuit of the given problem for transformer T1, we can write down II by Ti is equal to Vi Ti minus Vj Tj into Y. You can see from here, this is our II by Ti and the difference between the potentials here at these 2 points multiplied by the admittance. Similarly, for T2 we can write down the expression. On simplifying this, first let us see what we'll get. Vi Ti square minus Vj Ti Tj multiplied by Y. For T2, again we can write down the expression here for Ij by Tj. So what we'll get? Ij by Tj is equal to Vj Tj minus Vi Ti into Y, and rearranging the terms and simplifying them, Tj square Vj minus Ti Tj Vi, of course multiplied by admittance Y. So II will be, let us bring it here, Ti Tj Vi Y plus Tj square Vj Y. If now I number this as equation 1 and this as 2 and put both these equations in the matrix form, what we will get is II Ij equals Vi get this as Ti square Y minus Ti Tj Y minus Ti tjy tj square y multiplied by vi vj. Therefore, the admittance matrix is given by y equals y11, y12, y21, y22 equals ti square y minus ti tjy minus ti tjy tj square y. So this is the solution for the admittance. Hence, option D is correct. Thank you.